Hello everyone, welcome back to my YouTube channel. As in the previous video, we have discussed the concept of the empirical and the molecular formula and the steps how we can determine the empirical formula of a compound. So in this video, we will consider the another example in order to make the concept more clear. So here we have given a compound that contain 4.0% hydrogen, 24.27% carbon and 71.65% chlorine, and we have given its molar mass is 98.96 gram, and we have to calculate its empirical and the molecular formula. So first of all, in order to solve this type of numerical, we have to make a table, and in this table, in the first column we have to mention the elements whose percentage composition is given. So we have carbon, we have hydrogen, and we have chlorine. In the next column we write down the symbol of these elements. We have carbon, symbol for hydrogen is H, and for chlorine we have Cl. In the next column we have to mention the percentage of the element which we have given. So for carbon we have 24.27, for hydrogen we have 4.07, and for chlorine we have 71.65. In the next column we have to mention the atomic mass of element, as the carbon have the atomic mass 12, hydrogen has 1, and for the chlorine we have 35.5 gram. Okay. In the next column we have to calculate the moles of the element. In order to calculate the moles of element, we have to divide the percentage composition of that element with the atomic mass of this element. Now we have the 24.27% of carbon is given and its atomic mass is 12. Now for the hydrogen we have given 4.07 and the atomic mass is 1, and for the chlorine we have percentage is CH7 1.65 and its atomic mass is 35.5. So on the basis of these calculation we get the number of moles of the element carbon. Moles of the carbon we have 2.02, and for hydrogen we have 4.07, and for chlorine we have 2.02. In the next step we have to calculate the simplest molar ratio. For this we have to divide these values with the smallest of the values. So we have the smallest value is 2.02, so we have to divide by 2.02. So we get 2.02 divided by 2.02, that is equal to 1. Next we have 4.07 divided by 2.02, that comes out to be equal to 2, and this will also comes out to be 1. So as this ratio is the simple whole number ratio, so we can write out it as it is. We have 1 to 1. So therefore the empirical formula of this compound becomes, we have 1 carbon, we have 2 hydrogen, and we have 1 chlorine. So this is the empirical formula of this molecule whose percentage composition is given as. Okay. So now we have calculated the empirical formula of this molecule. So on the basis of this empirical formula, we can calculate the empirical formula mass of this molecule. So we have 1 carbon, so carbon have the atomic mass 12. Then we have the 2 hydrogen, and each hydrogen have the atomic mass 1, and we have the 1 chlorine is there. So therefore having the atomic mass 35.5. So therefore the empirical formula mass of this molecule becomes 12 plus 2 plus 35.5, so we get 49.5 gram. This is the empirical formula mass of this molecule, and we have given that the molar mass of the compound is 98.96. so this is the empirical formula mass, and we have given the molar mass of the compound is 98.96 gram. As we know that the value of N is calculated by the formula. We have N is equal to empirical, we have the molecular mass जो molecular formula के basis पे हमने mass निकाला है, and then we have the empirical formula mass of the compound. So therefore it will become, we have 98.96 divided by 49.5, so it will comes out to be 2. So value of N is equal to 2. So we have also calculated the molecular formula of this compound, and we know that the molecular formula is equal to N into my empirical formula of the compound. So therefore we have 2, and we have the empirical formula is CH2Cl. So therefore it will become C2H4 and Cl twice. So this is the molecular formula of this compound, and this is the empirical formula of the given compound whose percentage composition of elements we have given. So therefore in this type of numerical, first of all we have to write down which we have given in the numerical, then we have to calculate the mole of element, and then convert these mole into the simple whole number ratio. That gives the empirical formula, From the empirical formula we can calculate the empirical formula mass, and then with the help of this empirical formula mass we can calculate the value of n, and this value of n can be used to calculate the molecular formula of the molecule by multiplying the empirical formula with this value of n. So this is the molecular formula of this molecule. Thank you.